What's up, team? We're going to continue talking about equations of circles. Please watch the other video. First, this one builds on that. So as a refresher, here's the general equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared. H and k is the center of our circle, the coordinates, and r is the radius. Again, check that previous video if this is new. Okay, so here's a different situation. What if we're told that we have points A, B, and C with these coordinates -4, -1, 6, -1, and 6, 5. These 3 points are on a circle. That means they're on the part of the circle. They're not inside the circle. They're on the circle itself. They're not the center. They're just 3 of the infinitely many points on the circle itself. And the question is, what is the equation of this circle? Yikes, we have some work to do. We have to find the center, and we have to find the radius. You can do this all by hand. If you check my notes, I did it all by hand, and I walked through each step. Well, what I want to do in this video is show you how to do it on the Desmos. It's a little bit quicker, and really we're in the 21st century, so Desmos is always accessible. You can even get it on your phone. So I'm going to switch this thing over. We are going to walk through this thing on Desmos. All right. So what I've done is I went to desmos.com/geometry. This is not their graphing calculator, but I manipulated it in a way where it's going to work for me. So I put in this x and y axis by using their line tool, and then I plotted the 3 points that we were given for this problem. So A is down here at -4, -1. B is over here at 6, -1, and C is up here at 6, 5. This is kind of a cool one where these are they have the same x value, whereas these two have the same y value. So you have some horizontal and vertical stuff. So what we're gonna do here, we are gonna utilize a proof that Euclid did. So Euclid's third book is all about circles. That's where he introduces like how to start solving things with circles. And the very first thing he talks about is how to find the center of a circle. So how he did it is he said that if you have 2 or more chords of a circle and you find their perpendicular bisectors, they will always intersect at the center of the circle. And he demonstrated that this is definitely true. I'm not going to walk through the proof, but it's there. Book 3, Proposition 1. So we know that our 3 points, A, B, and C, I know they look like a right triangle right now, but these all lie on the circle. So the circle, I'm dragging my mouse here. It might look something like this, and it bounces out here, and it comes back. I'm not sure exactly. Like, I don't know where the center is. It's somewhere in here, and I don't know what the radius is exactly. But AB is a chord. CB is a chord, and AC is another chord. So let's actually put those in. I'm going to use the segment tool, and I'm just going to connect some dots, connecting A to B, connecting B to C, and connecting A to C. So these are 3 chords of our circle. Again, I recognize it looks like a right triangle. We're not going to do Pythagorean theorem in this situation. That's not what we're chasing at this moment. What I'm going to do next is I'm going to find the perpendicular bisector of all 3 of our chords. And the theorem says that they're all going to meet in the same exact spot, and that spot is the center of our circle. So there's a tool here, the perpendicular, no, let's use the midpoint tool, because we're doing perpendicular bisector. So with this tool, it's like cheating. Instead of using the formula, I can just click, and then boom, there's the midpoint. Boom, there's the midpoint of this chord, and boom, here's the midpoint of this chord. Now what I want to do is the perpendicular line tool. I'm going to click on the line, and then this creates the slope for me. And now I'm going to go exactly to that midpoint, and this is a perpendicular bisector of AC. I'm going to do it again for this chord on the bottom. Weird, looks like they meet right here. Let's make sure the third one also meets in the same place. Boom, it does. Okay, so what this means, I'm going to put a point right there, and we can even label it. This is the center of our circle. Center. And what are the coordinates here? Here's the origin, so it looks like it's at 1, 2. 1, 2. So this is the center of our circle. That's our h and k. So when we create our equation, we know our h is going to be 1 and our k is going to be 2. Great. Now, our next move, really our final move, is we need to figure out what the radius is. So that's the distance from the center of the circle to any point on the circle itself. So, gosh, what I'm going to do here is I'm going to create a line from the center to point B. I could do it to point A or C, but there's already a chord there, so it can get a little confusing. So I'm using our segment tool again. I'm going to connect the center to this point B, and again, it's almost like cheating because Desmos is awesome. I'm going to click on this segment. If you go to add label, the length label, you can see quickly right here, 2.92, that's the length of our radius. The length of our radius. Okay, so we're going to bounce back to the board. Our R is going to be 2.92. Our center is going to be at 1, 2. So H is 1, K is 2. All right, switch this around, bring back the big camera. So H and K, H we learned is 1, K we learned was 2, and R is 2.92. So we're going to put it in that form. X minus H, H is 1, plus Y minus K, which is 2, equals 2.92 squared. We can throw that 2.92 squared into our calculators if we want and get a number. It's going to be 8-ish. Not quite 9, because if it was 3, it'd get to 9. So it's 8 high, 8.8, something like that. But that's all I'm after for this particular one. If we go back to the Desmos we were just looking at, we can see if we use our circle tool, again, it feels like cheating. You just click on the center. This is how you start to create the circles. And if you move your cursor out, I'm going to move it and click on one of our points. And notice that this circle, it goes through the 3 points that we wanted it to. Pretty cool. It goes through A, it goes through B, and it goes through C. And the equation of the circle is the one that we just created on the board. This isn't the calculator tool within Desmos that I can demonstrate that for you. But you know what? Let's do that. Let's bounce over to desmos.com/calculator, and this will be the last thing I do in this particular video. So the equation that we came up with, I'm going to look on the board to confirm. It's x minus 1, and that quantity is squared. And then we added that to the quantity of y minus 2 squared, and we said that equals 2.92 squared. All right, so if we zoom in on this thing and kind of see what's going on, oh man, this thing is zoomed in so much already. I don't want those minor grid lines. I want the step to go by 1. There we go. So I can zoom out a touch. I'm going to put, just for reference, just so we can find it easier, here's the center. That's our claim, 1, 2. This is the one that we found just a moment ago. So here's the center of our circle, and it's at 1, 2. Great. The radius, it should be just less than 3, 2.92. So 1, 2, and yep, just less than 3. And it should be the same in all the directions. It's easy to check vertical and horizontal, just less than 3, just shy of 3, and just shy of 3. And of course, that's true everywhere, all around the circle. Okay, so this is one way to find the coordinates of the equation of a circle when you're given 3 points on the line. Sometimes you're given a diameter, sometimes you're given 3 points, sometimes you're given different information. You just kind of pick up the pieces that you have and figure it out. The key to this one is, again, we're leaning on Euclid, his proof that shows that we can find the center of a circle by connecting all the perpendicular bisectors. All right, go ahead, play with some practice problems. Let me know if you have questions. You got this.